Thank you for joining this webinar. If you're new to tracking research, also known as analysing longitudinal data, this webinar is for you. As always, I'm presenting from within Displayr, as it's designed for interactive presentations. But everything I show can be done in Q as well. So if you want to know how, just type some questions into the questions field in GoToWebinar, and I will get through to them at the end. Tracking research involves asking the same set of questions at different points in time, typically to a different group of people at each time period. The idea is to track what changes in the market. In some markets, continuous trackers conduct interviews every day, week, or month. However, dipsticks, either regular or irregular, are the norm in many markets. Tracking research involves solving challenges that can be put into three broad buckets: data management, analysis, and reporting. And that's the structure that we'll use for the rest of this webinar. There are four big data management challenges. The first is changes in the questionnaire. New questions are added, some are removed, new brands are added, new advertisements are added. A second is clerical errors. Working on tracking studies can actually be boring. Doing the same thing again and again, mistakes happen. The third problem is how you categorize the text data, or to use the market research jargon, how you code it. Bethany might code it in week 1 or month 1, Robert in month 2. And if they read the answers differently or interpret them differently or inconsistently, you're going to see changes in the tracking results, even though the market may not have changed at all. And the fourth big issue is that all of the above takes time and that costs money. So how do we solve these problems? It's easier said than done, but the biggest secret is to fight tooth and nail to avoid making unnecessary changes to a tracking questionnaire. People that are new to tracking studies often try and finesse the wording. They identify a question, they go, that's not very well worded, let's just tweak it a little bit, failing to appreciate that the whole purpose of the tracking study is to see how things change. And if the cause of the change is a change in the questionnaire, you've learnt nothing. The second point is you want to work harder than usual to get a really good data file format. So data file formats like SPSS and SSS data files contain lots of metadata, such as question wordings, the orders which questions were shown, things, which options were presented. And if doing a tracking study, when the questionnaire does change, and it inevitably does, having one of these great file formats makes it easy to detect the change and to report on it appropriately. By contrast, if you're doing your tracking using CSV files or Excel files, it's routinely the case that changes in the questionnaire won't be shown in these files, and so you'll miss them at reporting time, which means you can often confuse changes in questionnaires with changes in the market, which is obviously a terrible outcome. And I'll dig into the next 2 points on some more detailed slides. We'll start by looking at the wrong way to set up your tracker. You first interview everybody in the first wave of your tracker, and then you go, okay, for wave 2, I'm going to duplicate that project in my data collection software and send this new duplicated link out to, or this new link in the duplicated project out to a new wave of people. And that ends up with 2 data collection projects, and you then have 2 separate files because you export the data file from one and you need to export it from the other, and then you've got to merge them together. And merging them together isn't that hard. All software's got tools for it. In Displayr would be going into combine data sets by case. In Q would be going tools, merge variables by case. And the merged file just combines the 2 input files, as you can show here. The idea is conceptually simple, but this is a terrible way to work. What you instead want to do with a tracking study is you want to set it up in your data collection project, and you want to make sure there's a variable in that data collection project which records what wave it is, or alternatively just records the date, and most software will do that very easily. And you use that same project with that same link for all waves of the tracking study. And what that means is when you want to extract your data file, you don't have to do any merging. You can extract what's called a cumulative file with all of your tracking data. And that saves you a lot of time, but it's got an added advantage, which is data collection software tends to have good tools in it for keeping track of how your questionnaire has changed over time. And so by just having the one project for all of the waves of your tracker, it's very easy to audit and review and figure out what happened. Whereas if you're all done in separate projects, you tend to be in an ugly form of tracking hell, particularly once you get past 2 waves. The next issue with data management, or solution to data management, I should say, is just to automate as much as you possibly can. There's lots of stuff you can do here. Now, this isn't stuff for a beginner, and so we're going to talk about it in more detail in the advanced webinar, but I will show you the end game. The end game is you can have a study, and here I've got a nice little study that we've done. It's a big tracker. It's got lots of kind of tracking stuff, charts and stuff showing things over time. Now, I want to draw your attention to a few things. It's currently reporting data from July 2015 to September 2017. I'm going to show you the update soon. And my update, I'll choose a cumulative file, which has got additional data. It's currently showing us that 83% is one of the metrics here, and we can see the line chart showing 83% in the last period. And so in an ideal world, when you've automated everything, the tracking process is as simple as this. And I'm showing it to you on display. You can do the same things in lots of tools. We'll talk more about that next week. I click my computer. I find where I've got my data. This is my cumulative file. It goes all the way to December. Remember, we were seeing before that number of 83%. You can see it in the background. So Displayr is now ingesting the data. It's updating any calculations, updating any tables, and it will soon start to redraw the visualizations with the revised data. And we'll see this 83% drop down to 78%. If you look carefully, you'll see this has now got that little decline in it. Everything else is updated. So that's the end game, completely automated tracker. Now, as I said, we'll talk more about that next week. I say next week, in 2 weeks in the next webinar. When we're doing analysis, we've got 3 key issues. We want to find meaningful changes in the data. We want to avoid reporting noise and telling people it's meaningful when it is just noise. And we want to prevent confusing trend with seasonality. What I mean by that is there are many markets where there's natural variation within seasons. Some brands are stronger in winter, some are stronger in summer. And you see that every year. And the way you want to focus your tracking in those markets tends to be you want to compare results to what they had 12 months ago, because that way you can rule out the seasonal effect. And I'll talk a little bit more about seasonality in the next webinar, but I'll show you how to do that 12-month comparison now. So the 3 big solutions to these issues are use automated stat testing to help you work out which changes are likely to be meaningful, use weighting, and spend some time thinking through and just trying to work out what causes what. That's a great way of working out if the changes are meaningful or not. Anyway, let's dig into each of these topics. So I have some data here on brand awareness. I want to see how it changes over time, and I'll first use a kind of wave variable, and this is just a normal categorical variable that just records different waves of the survey, and this is commonly how data will be set up for a dipstick study. Now, if you're new to tracking research, and you should be, this is a beginner's webinar, you might be tempted to look and go, oh look, Arnold's went up in wave 5, and that would be potentially, or sorry, went down, I should say, it's red with an arrow, and that would be a mistake because stat testing generally is not designed with tracking in mind. It's generally designed to compare one column with all of the other columns in total. And so if we want to actually force the comparison to just be doing a comparison with specific columns, we've got to do some extra steps. And there's a few ways we can do this. One is, if it's a categorical variable in the columns, we can just select those columns, right-click, and delete. And this will force it to compare to all the other data, which is only the previous wave. And now we can see that the only significant changes in these from wave 4 to wave 5 was for breadbasket and woven. just reset those table categories. Another approach, which is very common as well, is to change the style of significance testing to doing column comparisons, where we have letters representing each column. And so wave 4 is a D, wave 5 is an E. So when we're looking at wave 5, we're just trying to look for any mentions of D, because that tells us there's a significant change. And so we can see again for breadbasket and Nuovo burger, we are indeed getting those changes coming through. So it's exactly the same result, just presented in a different way. Now, this is for a dipstick tracker. If we've got a continuous tracker, we always want to set up the data as a date variable. And if you look here, the little icons here, and the same concept exists in pretty much all software, but wave is shown as categorical, date has got a little calendar next to it, and I'll drag that across, and it's going to present the data differently, and we'll have more options because dates have got various inbuilt automations with them. Now, we've dragged this on, and now we've got so many columns of data. This table is way too big, so we need to simplify it. The first thing that we want to do is we'll change it from months to quarters, which will simplify it a lot. Because it's date data, we can just do that entirely automatically. The second thing we can do is we can change the way we're doing the significance testing. I don't love these column letters in general, and I think for trackers, it's a bit confusing. So the way I'm going to do that is I'm firstly going to change it, wrong option, I'm going to change it back to using arrows and font colors. But again, we have that mistake that I was telling you about before, where if we look here, it's showing, for example, Burger Shack went up, but it's not really comparing Burger Shack to the previous period, it's comparing it to all of the periods. And so what we need to do is we need to go into the significance testing advanced options and just explicitly tell it to compare to the previous period. And now we see a completely different result. We see that Pret A Pain is actually the only brand to move up in the last period. And I'm focusing on the last period because typically that is what's most interesting to the stakeholders of a tracking study. What about if we want to compare to 12 months ago? How do we do that with this type of data? What we do is we're going to create a new variable. So I'm clicking on date. I'm going to go down here, insert a ready-made formula. I'm going to choose something called contrast periods. Let's add this new variable. Let's drag it on top and replace the date variable and have a look to see what we get. And so now we're comparing August with September, and it's not finding anything different, but we want to look at quarterly data. So I click on the variable again. And so now we're seeing the quarterly data, and we are indeed seeing an increase in Pret A Pain, which again, we've seen as a result in our earlier analyses. What we will do here though is it's currently comparing Q3 with Q2. We want to make it do the comparison with Q3 2016 to remove the seasonal effects. And that's interesting. We see a whole lot of things have actually moved. And so now we've got a bit of a conundrum. When we just look at the last quarter, we see Pret A Pain has grown. When we look at the data from 12 months ago, we're seeing we've got 4 brands moving. Are they seasonal effects or is something else going on? And we'll return to that in the shortcoming section on reporting and data visualization. The second big thing that we want to focus on when we're doing analysis is we want to look at weighting. Now, in all studies, we get over and under representation of different subgroups. For example, in a tracker, we may have too many men one month and too few the next, and weighting can correct for this. Now, with a tracker, we can actually guarantee we're going to have movement every month just due to this noise. Therefore, we pretty much always want to use a weight to correct for it. Now, if you've never done weighting before, I'd encourage you to check out the webinar that we did recently on how to use weighting to fix data problems. Here, I'm just going to show you the outcome of it, where I'm going to apply the weight to this table. And interestingly enough, we see once we apply the weight, that is, we try and strip out the random noise, which is what the weighting is doing, we are finding a significant difference. So the random noise, which is always in our surveys, had hidden the difference. And it can be the other way around. You can see no difference with the unweighted data, and it becomes, sorry, no difference with the weighted data, but a difference in the unweighted data. So always weight your trackers. Automated stat testing and weighting both help us to sort out the true differences from the random noise. And these should be augmented with attempts to understand causality. That is, trying to figure out what has caused a movement. If you can find other data that corroborates the differences you see in the tracker, that's a good sign. Examples of other data to look at are marketing activities. If we see an increase at the same time we've changed our advertising campaign, that tells us something. Distribution of price changes that align with movements also tend to make us more confident about the conclusions from the research. Do our changes in claimed buying rates align with changes in actual sales data? That also makes us more confident. Other survey results, Google Trends, lots of ways that you can use other information, and you should use other information when reporting a tracking study. The last thing you can do is you can attempt to decompose changes over time into two causal factors of them, one which is changes within subgroups and the other which is changes in subgroup size. And this fascinating topic will be the centerpiece of our next webinar. So the third bucket we're looking at is reporting. When we report our tracker, our first key challenge is we want to make it easy for the audience to see what's changed. And we want to prevent them from seeing noise and interpreting it as change. And often most difficulty, we want to prevent boredom. So how do we do this? Well, we are going to dig into the first few of these, small multiples and smoothing. And again, we'll get more detailed in the advanced webinar that's coming up. The last point to talk about here, and this is just, again, if you're a beginner, you won't know this, but if you're an experienced researcher, you'll already be doing this. There's a standard kind of way that you present tracking to try and avoid boredom over time. Wave 1, you present your results. Wave 2, you show what changed from wave 1 to wave 2. By the time you get to wave 3, you introduce rotations. And these could be new questions that only come into your questionnaire occasionally, or it could be a deep dive in your analysis. Maybe wave 3, you focus on brand health. Wave 4, you focus on ad effectiveness or something like that. And in our more advanced webinar, we're going to talk about one type of deep dive, which is identifying laws of the market. Anyway, let us get into small multiples and smoothing, because they are two of the really coolest and most useful things that you can learn to do. Every now and then, I see a visualization that's just so horrible, I have to take a screenshot. And this is such a visualization. Now, I've named it spaghetti because generally bad line charts look like spaghetti, but this one actually looks much more like the wires from some bomb being used to blow up a building in the kind of movie that I might watch late at night. I've disguised the brands here because, let's face it, everyone's going to be embarrassed who was involved in this particular visualization. How can we improve it? Well, having an interactive dashboard rather than a PowerPoint's obvious improvement, because then the user can interact with it. But the challenge we have with this data here is it's actually very hard to find anything here looking at it. And don't have to take my word for it. Look at the crown. What can you work out? I'll give you 5 seconds. Yeah, 5 seconds wasn't enough, was it? It's just no real easy way to find the pattern out. Let us change this to a small multiples and just saw a quick preview of that. I'm going to go and I'm going to change it to an area chart, and I will choose the small multiples. And small multiples is just lots of small charts, but they're not on top of each other, which makes it really easy to see what's going on. So here's the crown, and you can easily see when it had spikes. Much, much better visualization. Now, small multiples were invented more than 200 years ago by a great guy called William Playfair, maybe somebody else before him, who knows. And they've been considered best practice in data visualization for about 40 years, but you don't see them so often. Why is that? Well, it's really explained by the great mathematician who said, Lofty Zeta, it's an awesome name. It's actually the name that's the greatest thing about Lofty Zeta. And he said, when all you've got is a hammer, everything starts to look like a nail. And in the world where most tracking research is presented using Excel charts or PowerPoint charts, they don't support small multiples, they just support the line chart, which is why we see so many line charts. But if you're happy to get out of that world, you can do much better visualizations. using small multiples. Another example. This is the brand awareness data that we're looking at before. You can see here, it's kind of spaghetti. It's a bit hard to see much. It's easier than the example before, but again, as small multiples, how much clearer is it to see that we've really only got two brands where stuff is going on. Now, small multiples are the #1 data visualization tool that you really want to be using with tracking research. It's just so good for them. #2 is to use smoothers. We've got some data here on customer churn. You can see it's jumping around a fair bit. It's hard to see a pattern or present a very clear pattern from all of this. Now, one way you can deal with this is you can aggregate it, say looking at quarterly as we did before. But the more common approach, I wouldn't say more common, another approach is to put a smoother on it. Now, the simplest smoother is one that we'll all know, which is to draw a straight line, which is very smooth. It's a line of best fit, like a linear regression line, which is what I've drawn here. Now, the linear regression line suggests it's going up over time, but there's really more movement in that. So what else can we choose? Now, in market research, it's quite common for people to use moving averages, and often they're called rolling averages. And here is such a smoother. And it's called a smoother because it smooths out the patterns in the data. But if you look carefully, you'll see this rolling average is doing a terrible job. Notice it's not showing anything for the first 5 periods of the data, and that's just due to its math doesn't work very well. It doesn't work for the first 5 periods of data. Secondly, note something quite terrible. It's showing us, you can see there's kind of a peak here for the data, but the peak appears in the moving average later. Again, peak here, the peak appears in the moving average later. And that's actually a systematic problem with moving averages. It's why they're really junk. They're one of these techniques that gets taught in introductory business statistics, but what often doesn't get noted is that it's just an introductory technique to help people understand. It shouldn't actually ever be used, and it shouldn't ever be used. And I'm going to explain to you why. But first I'll show you what the better alternatives are, because there are much better alternatives. One of them is called novice. When we change to novice, we will see it's doing a much better job at capturing the patterns in the data. Another one, which I particularly like, I'm not sure if I like it because I like the name or because it's better, is Friedman's Super Smoother. It's going to have a little more wiggle in it. Again, it's doing a much better job at showing the trend. Now, some people get concerned, like, how do I choose one of these smoothers? You choose the one which does the best job based on your eye. It's that simple. How do they work? They're both really complicated math. And I think it's the complicated math, which is why people prefer moving averages. So, because moving averages are easy, but let's look at the math of a moving average to quickly understand why it's garbage. So here I've got my 6-month moving average that I showed you before. When I hover over it, it tells me my fitted line is at 6. So, and that was for October 2018. The way it's computed is you take that period and the previous 5 periods, so you've got 6 in all, and you average them. And you'll remember the formula for an average, and that gets you a score of 6. And don't worry, we're going to get somewhere pretty cool with this math. So let's say we wanted to do the number for November. Well, we get rid of the first month and add in the November month, which is what I've done here, and we get a score of 6.4. So what has changed over time? Well, you'd say that we went from 6 to 6.4, so churn increased by 0.4. 6.4 minus 6. That's what you'd obviously want to do. But let's substitute these early calculations into this 6.4 minus 6. And remember rearranging terms from school? I've collected together everything above the divided by sign. This has got a single 6 here. And notice a pattern here, right? This 7.8 is add on the left, subtract on the right. 4.3 plus here, minus here. 7.9, 7.9. So a lot of these numbers are going to cancel out. And when they're cancelled out, we see that when we compare the November data with the October data moving average, that 6.4 versus 6, we're just really comparing the November number with the May number and dividing by 6. And so we're only comparing 2 months, 6 months apart, which is completely useless. And the fact that it doesn't move all over is just because we've divided it by 6. Moving averages are garbage. So we've covered the basics of how to do tracking research today. In a couple of weeks, we'll return for a much more advanced webinar designed for more technical people, or that's right, for more experienced people, or people who want to become more experienced and more technical. There's going to be lots of little things that we're going to focus on, various technical issues. The most interesting thing, I think, for most of you will be this thing of understanding changes in terms of changes within subgroups versus changes in group size. Later this week, we're going to email you a recording of this webinar. And if you have any questions, now's a great time to add them into the questions field in GoToWebinar, and I will get onto them. So what questions do people have? The first question we've got from Sven is, do you really have to change to use a single data file to do your analysis? Yeah, you do have to do a single data file to do your analysis. You can never, Displayr will allow you to load 2 data files, but to do all the stat testing, all of your tabulation easily, you just want to have a single cumulative data file always. And there's a follow-up question, which is relating to, is it really so bad to have 2 separate projects? Look, it is bad. You just want to typically have that one project. You can survive. There are the merging tools that I showed you before. They work quite fine. Brian asks, how do we statistically test for trends over time? I'm going to focus on that in the next webinar. And the next question we've got from Richard is, when you use the compared to previous period SIG testing, do you have to change the correction, i.e. false discovery, Bonferroni? That's a great question, Richard, and there's 2 parts to that answer. The first thing is, if you have the correction on, such as false discovery or Bonferroni, no, you don't have to change it. Now, Displayr doesn't put those corrections on by default. Q does put them on by default. Why are they different? Well, when we wrote Q, we tried to do everything in the way that was definitely the best from our point of view, which was to have the corrections on by default, but most users don't like to use them and got confused, which is why they've been turned off in the defaults. I definitely wouldn't be ever using a Bonferroni in tracking research. Bonferroni it's one of those techniques that was invented a long time ago, and it's just terrible. It's extremely poor form of multiple comparison correction. The FDR, the false discovery rate's much better. I tended to use it whenever I was presenting tracking research. And apologies if I've mispronounced that, says, can we automate the importing of data if we continuously get feedback? Yes, you can, and there's various ways of doing that. So for example, let's say I had, and there's lots of different ways, but let's say that I had a data file and I was automatically updating it every month and it was stored on some cloud drive or automatically every night or whatever. I would just click here and just schedule the update schedule, so maybe the update every hour or whatever. There are lots of other kind of more complicated tools for how you would update the importing, and lots of our clients do that. And Wiam also says, from Snap Survey, our own data warehouse of having received, okay, I think he was, hold on, let me just try. No, I don't have the full sentence there, Wiam. I think I've lost a little bit. If you can add it back in. Noah says, so we have to merge data sets from various periods first before uploading as one data set only onto Displayr. Yeah, and you can do the merging in Displayr, so you could upload your files and then do this combine that I talked about. And it's not just a Displayr thing. Any software that you're using to analyze tracking data, you need to have a single cumulative data file. It's completely standard that you do it that way. And there's a whole lot of complicated reasons for it. And I say I'm sure there's some weird software out there which does it in the background, but it's pretty standard to have a single cumulative data file. Mallory says, how do we go about incorporating question changes using different brands that vary to track per wave? Well, if you've got, when you merge together the file, let's say the questionnaire changes over time and new brands are added to a multiple response question, that'll just appear as additional columns in the file. And what'll happen when you import the updated file is, and you click update like that, Displayr or Q will say, hey, I've got these new variables. It'll try and group them together, and then what you'll see in your resulting tables and charts, and I'll go back to this one we're looking at before, is let's say that you've got a brand that was added in and it's not there for the first 4 quarters, you'll just have blank data for the first 4 quarters. So the process is not super difficult, but if you make a lot of changes to your questionnaire, it can be pretty painful. Nurse says, I missed the first part. What does cleaning of the data then have to be done prior to uploading? Yeah, not always, you've often got to clean your data prior to uploading it. And we've just done a couple of great webinars. Actually, maybe they're not great. I did them, hopefully they're great, on data cleaning. And so I'd encourage you to check them out. If you go to our website, resources, and go down to ebooks and webinars, you'll find those webinars on data cleaning, a beginner's guide and an advanced guide. So yeah, data cleaning is very important. I'm also going to talk a bit more about data cleaning for tracking and automation next week, in 2 weeks, I should say. And Mallory says, if wave 1, we want to consider 3 brands, and in wave 2, we want to consider the same 3 brands plus another brand. Yeah, as I was explaining before, Mallory, it's not actually a problem at all. You're just going to have some blank rows in the table. It's as long as, and particularly as long as you've used the same project to collect the data, it's very, very easy to deal with those kind of things. And Will says, hi Will, what happens when new questions get added when you're accumulating data? And so accumulating, that is creating this cumulative data file, when you import, it will just add additional variables. And I will add this as something that I'll show in the advanced tracking webinar to show you the effect. Displayr and Q have got nice little tools that make it reasonably easy to manage these changes. I say reasonably easy because it's always the case that when you change a questionnaire, you're creating additional work. And Riham says, my second question was, can the data be transmitted from SNAP surveys automatically too? I don't know much about SNAP surveys. Now, a lot of the data collection platforms have a tool that allows you to automatically export files to web locations. And so maybe SNAP has that. I can't talk about that in much detail. If SNAP has an API, and I have a feeling it doesn't have an API, but if it has an API, you could use Displayr's API if you're a good coder to import the data that way. That would be another approach. If it's a simple survey, and this is only if it's a simple survey, and the data was sitting in a database that they give you access to, you could import it via a SQL query. You generally don't want to do that with a survey though, because that will just get the numbers, it won't get the wording changes in. It can be a bit dangerous. All right. And that is all the questions. Look, for all of our customers out there, thank you for being our customers. For everybody who watched the webinar, I appreciate your attendance. And hopefully you will see enough that you'll think in 2 weeks' time when we do the advanced tracking webinar, I'm going to watch that. Anyway, keep safe, everybody. Bye now.